Sir, it is visible, sir.
Okay. Okay, so we will continue with the rotational motion. We'll start rotational motion today. So before going into details of rotational motion, first you have to understand that what is a rigid body, because in this chapter we are going to study about the rotational motion of rigid body. So first of all, from the definition itself, name itself, it is clear, rigid. You know. So first of all, ideal rigid body are those in which separation between any two particle of the body remains the same, no matter whatever external force is applied to it. Those are called as ideal rigid body. So in an ideal rigid body, suppose this is an ideal rigid body. It can be of any shape and size, anything. This is an ideal rigid body, suppose. Ideal rigid body means that if you take any two particle inside the body, any two particle, not only these two, any two, there will be some separation between these two particles. That separation will not change. Relative separation. Relative separation between the two particles will not change no matter whatever is the external situation, external force applied on it. If that is the case, then we say that it is a rigid body. If separation between any two particles of the body will not change, then definitely shape of the body will not change. Such bodies are called as a rigid body. Ideal rigid body. Okay, understood. You have any doubt in this? You can ask your doubt. So if this is an ideal rigid body and this d is the separation between the two, any two particle, then this d will not change with time. D will remain constant. No matter whatever is the external force acting on it. But you know that separation between any two particle of any body can be changed by exerting some external force. Maybe in some case you will have to apply a large external force, in some case low external force. So what you understood that nobody in this universe is actually perfectly rigid body. There is no ideal rigid body. So ideal rigid body is just a concept. It do not exist. But if ideal rigid body do not exist, then what is a rigid body for our discussion? So for our discussion, whenever we say rigid body, you have to understand that we are not talking about ideal rigid body, but we talk about practical rigid body. Now, practical rigid body are those whose shape and size do not change under normal conditions, under the given condition. For example, in a question, it is given that a fan is rotating at this angular speed. A fan is rotating at this angular speed, then we will consider that okay, that fan is a practical rigid body, and while it is rotating, its shape and size is not changing. Are you getting it? You have any doubt? You have no doubt, right?
No doubt, sir.
Okay. Okay. So if you have no doubt, then we'll go to the next. So that is a rigid body. Now let's talk about center of mass. What is center of mass? First of all, you have to understand center of mass is just a hypothetical concept. There is nothing called as center of mass. First of all, means center of mass is a point where all the mass of the body is assumed to be concentrated. It is not concentrated, but it is assumed to be concentrated. assumed to be concentrated. There is no such point in any body where its entire mass is concentrated. But this is a hypothetical concept that we have developed. Why we have developed this concept of center of mass? Because the application of Newton's law of motion to bodies, not to particles, to bodies or system of particle. Bodies are nothing but, rigid body is nothing but a system of particle because it is made up of large number of particles. So application of Newton's law to a system of particle or to bodies becomes very simple if you introduce this concept of center of mass. That is the use of this concept of center of mass. Not only application of Newton's law of motion, but many other concepts also becomes, है ना, application of many other laws and principles also becomes very easy when we introduce this concept of center of mass. How it becomes easy, that you will understand in this chapter. As we will go ahead, you will understand that how calculation of few things becomes very easy because of this concept of center of mass. Now, in case of a regular shaped rigid body, regular shaped, uniform body of regular shape, its center of mass is generally located at its geometrical center, or you can say centroid, geometrical center. For example, if a disk is there, then its center of mass will be its geometrical center if the disk is uniform. If the disk is non-uniform, then it will not be geometrical center. Okay. Now here you have to understand that center of mass is also defined mathematically in a very simple way. So you have to understand, suppose that this is a line which we call as x-axis, okay? And on x-axis there are different particles are located. So let's say here is the origin, okay? And different particles are located on x-axis. This is origin, let's call it as x equal to 0. And then there are different particles which are located here on x-axis. Let's say this particle having x coordinate x1, x2, x3, x4, x5, like that. Okay, x6, x7, all these particles are there. Now you have to understand that if the x coordinate of all the particles are, let's say for this particle it is, you can call x coordinate as x1, for this you can call x2, for this you can call x3, and so on. And their masses, all the particle will have some masses also. First particle you can say that okay, I will take its mass as m1. Second particle you will say that okay, I will take its mass as m2, and so on. M1, m2, x1, x2, m1, m2 up to mn are the masses, x1, x2 up to xn are the coordinates of the particle. So in that situation, if you find this product m1 x1 plus m2 x2 plus m3 x3 like this, they have done some mistake here. So if you find this product, so on, means m1 x1 plus m2 x2 is written plus m3 x3 plus dot dot dot. For all the particles, if you do, then this is called as the first moment of the system with respect to the origin, because here x1, x2, x3 all are the x coordinate. X coordinate means distance from the origin along x-axis. Now you have to understand that center of mass is that point about which mass moment, or you can say first moment of the system, becomes 0. So what I'm trying to say is that if you replace this origin by a set by, or you can say that if about the this point which we were calling origin, if you find the mass moment, or you can also call it as first moment, which is nothing but summation of mixi, and it turns out to be zero, that point is called as center of mass. So center of mass, if you say, if you calculate the mass moment of the entire system about the center of mass, it will come out to be zero. Or this is the way center of mass is defined actually. Center of mass, you can say, is a point about which mass moment of the entire system becomes zero. That's it. This is the mathematical, you can say, definition of the center of mass. Mass moment of the entire system about the center of mass is zero. Understood?
Sir, here the reference is the frame of reference only,
Speak
sir.
louder. Your voice is not coming.
Sir, here origin means we are taking coordinate with respect to origin, no, sir. Means origin means the frame of reference origin only, no, sir.
Origin means
Here the frame of reference origin only, no, sir.
no. Here x1, x2, x3 all are distances from the center of mass.
So not generally the center of mass we use formulas, no, sir. M1 x1 plus m2 x2 by like that.
Speak little
So,
louder, louder.
sir, in center of mass we use formulas HCM, ICM, HCM, no, sir.
Yeah.
In those formulas, the coordinates are from the origin of
Yes.
frame,
Yes.
frame of reference only, no, sir.
Yeah, that is from the origin. That's a different thing. That is the formula of x coordinate of the center of mass. We are not talking about that. What we are talking is that the mass moment about the center of mass, not about the origin. About the origin, it is not zero. Mass moment about the center of mass is always zero. This is if you take it from the origin. For instance, suppose x1, x2, x3 all you take from the origin. Then this summation is called as the moment of the system with respect to the origin, and it is not zero. That you have to understand. It is not zero. What I am talking is a different thing. What I am talking is mass moment about the center of mass of a system is always zero. This is the way how center of mass is defined. Suppose, so the formula that you are talking is a different thing. That is about the x coordinate of the center of mass. And that is not zero. That's why you get the x coordinate now. In that formula, suppose if that term will become zero, then whole numerator will become zero now.
Yes, sir.
Yeah, now you can say that yes, we will get exactly the same thing if origin is the center of mass. Imagine a special situation I'm saying, not always. Just imagine that origin is the center of mass, then this will be true, right? Because then by this formula you will get, if this formula and divided by the total mass, you will get x coordinate of the center of mass, and the center of mass is origin, so x coordinate will be 0. Then you will get this.
Sir, here origin
But don't
means
try to connect it with that one, you will be in trouble. So what I said, just write it down, that mass moment of the system, any system, about the center of mass will be always 0. We are not talking about x coordinate of the center of mass. No, we are only talking about mass moment of the system, or it is also called as first moment of the system. Okay. Now let's go to the next. Now here you can see that these are the some regular geometrical shapes. Their center of mass will lie at their center. So their center of mass is lying at their geometrical center. Okay. For regular mass only, regular distribution means uniform distribution for regular bodies. Okay. Now let's come to the center of mass. Now we are talking about finding the coordinates of the center of mass. Now we are talking about the coordinate of the center of mass. And this is obviously with respect to origin, because we are talking coordinate of center of mass. Any coordinate of anything is always from origin.
sir, here origin means the the frame of
Origin means
reference
your choice, anywhere.
means the frame of reference which we choose in kinematics like that only which we get concerned or something.
Um, yeah, yes. But the thing is that, yeah, yes, so the same frame of reference. But then you have to understand that here, uh, exactly same frame of reference, same thing, no difference.
Yes, sir.
So the point where the axis will intersect, that is origin, and that is attached to something which you can call as frame of reference. So center of mass. So if there are n number of particles having this masses m1, m2, m3, and they have x coordinate this x1, x2, x3 dot, then center of mass is given by, then x coordinate of center of mass is given by this form. Here all the coordinates are from the origin, x1, x2, x3, they are x coordinates. Coordinates are always from the origin. Okay, so this is the formula of finding the x coordinate of the center of mass. Now, similarly, y coordinate of center of mass. So, in the formula, in place of x, you will replace with y. There may be a body which is a system of particles, and all the particles are in 3D space. So, its center of mass will be in a space, and it will have x coordinate, y coordinate, z coordinate. So, for individual, you will have to find x coordinate, then y coordinate, then z coordinate by this formula. Till now, you have any doubt, you can ask. Now you can see center of mass of a two particle system. So there are two particles, they are separated by some distance. You have to find their center of mass. Just now you have seen the formula. Just you have to use that formula and find the center of mass. So do it. Or you can also, without using that formula, also you can do. If you just understood the definition of center of mass. Definition of center of mass says that it's mass moment of the system about the COM is 0. Summation of mi and xi, but this I with respect to COM. If you take, this is called as mass moment about center of mass, and that will be always 0. From this formula also you can find the center of mass. This is the basic actually. If you don't want to use this formula, then you use directly the x coordinate of center of mass formula. So solve it, find it.
So we generally use, so means center of mass
Speak
of the two
louder,
parts.
speak louder, speak louder. You are not audible.
So center of mass of generally two particle means if the motion of the two particles combined will be same as that of center of mass. No, so we can say no. Sir.
I have not understood your question.
So we are taking two particles, sir. The
Okay.
motion of the particles combinedly is same as the motion of center of mass. We can say, sir.
No, no.
Sir, but
Suppose
we
the
only
two
say that
suppose the
same
two
like.
particles are going in a circle. Center of mass is not moving.
Sir, but where it gives, you said that it
Two
gives the
particles
overall
are
motion.
moving in a circle. Center of mass is at rest. Now your definition is not working, na, here.
Sir, but you said that center of mass will give overall motion of an object.
No, not overall. I have just given you one example. Two particles are moving in a circle about the center of mass. This particle, both moving. What will be motion of center of mass? No motion, right?
So there will be a motion actually, depending
Means
upon the
if the two particles are moving in a circle of the same radius, let's say this R1 radius, R2 radius, then why center of mass will move? Center of mass will be always here only, no? Are you getting?
yes, I'm getting.
So it does not represent the motion of the overall body, because there can be a situation when the all the particles of the body is moving, but the so it does not represent the motion of the particles. But yes, later you will understand that how it is related to how, you know, motion of center of mass is related to the motion of the whole system. That you will understand later. So till now, just find the position of center of mass.
So then, what is the use of center of mass, sir? If you want to use
Already
it,
explained you what is the use, and you will understand gradually. So first use is that application of Newton's law becomes very simple if you know the center of mass of the whole system. And not only application of Newton's second law, many other things like calculation of momentum of the system, kinetic energy of the system. Later you will understand. Also, we can describe the complicated motion of the particles of the system in a very simple way if we know its center of mass and the velocity of center of mass, these things. Then dealing with individual particles will be, suppose there is a system of 1,000 particles, and 1,000 particles are moving in different way, in a very complicated way. Every particle suppose moving with different velocity, different direction. But even for such complicated system, its entire motion can be described. When I say motion can be described, it's not about the, it's about the application of some of the laws, you know, law we can apply in a very simple way by using the concept of center of mass. For example, we can apply the Newton's second law. We can apply the conservation of momentum. Okay, and We can also apply to individual particles of the system, but it is practically very difficult, na?
Yes, sir. It's
And
practically
maybe that the motion of individual particles will be very complicated, but that complicated motion of individual particle, so there are a lot of particles in the system. The whole system we can treat in a very simple way, but if we go each particle by particle, then it becomes very complicated. So to deal with entire total system, overall system, the center of mass is introduced without going into the each particle by particle, you know. So you will understand gradually. The whole chapter is about that only. Find the center of mass position. Complicated motion of a system can be analyzed in simple way with the help of center of mass concept. Many problems of the mechanics you can solve easily by applying the laws, you know, not to individual particles but directly to the center of mass. So center of mass simplifies the, you know, lot of calculations for the whole system. Are you getting the answer in this case? You can ask your doubt for this particular case. You have to find their center of mass. Two particles are there, m1 m2 mass, separation between them r. You have to find where is its center of mass. Now you can ask your doubt.
sir means sir nowadays in the Newton's laws of chapter we are applying Newton's Faber diagram means we are applying all that forces. We are assuming all that forces are acting on the center of mass only. We are assuming, sir.
No, no. So till now you don't know. Till now you don't know Newton's law for a system. You only know Newton's law for a particle. Till now we have not discussed anything about the Newton's law for a body, for a system, only for particle. So in this chapter, again, we will discuss Newton's law for a system, and then we will talk that okay, net force, and we will prove it also. That why it is mass times acceleration of the center of mass. Are you getting? Net force acting on the whole system. These things we'll discuss again. Again, you have to study. Till now, you have not studied that. Till now, you have only studied Newton's law for particle. Even if you applied Newton's law to a car or to a planet in Newton's law chapter, but you treated them as a single particle. Are you getting?
Yes, I am getting, sir.
But now in this chapter, we will study that if it is not a single particle, if it is a system of particles, then how we can apply Newton's law. That we will discuss. That we have not discussed till now. So, got the position of center of mass. Keep asking, keep asking,
So means
keep
up to
asking
now,
your doubt.
even however the body is we consider as particle, from now we will consider body as body and apply all formulas now, we can say.
Yeah.
By the
So
principle of
till because we just now we introduced rigid body. Before that, we don't know what is a body. Means for us, before that, the body is just a particle. But now we introduce rigid body, which is a system of particles. So now onward, we are not talking about single particle. Now we are talking about system of particles. Every body, now we will treat them as system of particles. Means if a disk is there, now we will not see disk as a particle. We will see disk as made up of large number of particles. It has a center of mass. If you're applying force, then we will see where you are applying force. You are applying force at the center or at the tangential to the disk of where you are applying. That is also important. But why we were not discussing these things in the Newton's law chapter, that where the force is acting, a block is hanging, we were not saying that the where the thread is connected to the block at the center or near the edge, because we were treating everything as a single particle, everything as a single particle. That's why. And you know practically that if there is a rod is not a particle. Rod is made up of large number of particles, right? So now you will understand that also, that why we were treating rod as a particle in Newton's law, and why we cannot do the same now. Think about it. That is the real question. If a rod was there or a block was there in Newton's law, we solved all the question by treating them as a single particle. For example, a car is there moving on a curved surface. We were saying that okay, net force on the car is mv square by r, centripetal, moving on a curved surface. Are you getting?
Yes,
We
sir, I'm
never
getting.
said that oh, car is not a particle, car has front wheel, back wheel, this wheel, that wheel. Car is not even doing translational motion, car wheels are doing rolling motion, and we were not doing these things because we were treating car just as a, in place of car in the question, if they give you a block, then also exactly same formula you will write. So we were treating everything as a single particle. But now what is the problem? Think about that. What is the problem that now we cannot do that?
So now we are defining center of motion for a.
No, but no, that is not the correct answer. But why we are defining center of mass? Why there is need for that? Think about that. If we are now defining center of mass, why we have not defined center of mass in Newton's law chapter, and why now? Because now you cannot do without the concept of center of mass and without the system of particle. Now you cannot do by, and just now I have given you example also.
Yes.
You asked that the motion of particle represents motion of center of mass, and I have shown you that no, particle is moving, center of mass not moving. So that is not the case. Why there is a requirement of this concept of center of mass? Why we cannot treat a rod or a car just like a particle now? Why we have to treat them as a system of particles? Because now we are going to
Define center of
discuss
motion.
rotational motion. Are you getting? Because now we are going to discuss rotational motion. That's why. Till now, have we discussed rotation of anything? No.
No, sir, we can't.
Till now, we were doing translational motion. And when something is doing translational motion, every particle of the system has the same velocity, same displacement, same acceleration, same motion. That's why. No need of saying that, no need of shape and size, because whatever one particle is doing, other particle is also doing the same thing in translational motion, but not in rotational motion. In a rotational motion, if you look at a fan, you will see that one blade of the fan is going toward east, then another blade of the fan is going toward west. Are you getting? Their motion is not identical, although the center of mass is not going anywhere. But can you say this particle and this particle are exactly identical? Everything is same? No. Yes, they are going in circle, but then can you say this particle and this particle exactly same thing? No. This particle is going in a bigger circle. This particle going in a smaller. Are you getting?
Yes, sir, I'm getting, sir.
Now, lot of things have changed. That's why we are introducing this. Because now we cannot treat a rod as a single particle, because the rod has different particle and different particle are doing different type of motion. Maybe the motion looks same, but then their velocity may be different, their direction of motion will be different, the distance that they cover may be different. All these things are now different. That's why. Solve it quickly. Then we'll go to the next.
So, man, since we are starting rotation motion, we need to consider these all topics. No, so we can
Yes, but then again you have to understand that then you have to go deeper. Of course, because we are starting rotation, that's why. But you have to think that what is there in rotation so that we cannot treat the system as a particle, and we have to think about individual particles. We have to look at anything like a collection of particle and not just one particle. That is the real question.
yes, sir.
Okay. All the answer to all those questions will come in this chapter. So don't waste your time. Just find the center of mass of this system. Position of the center of mass. Or if you have doubt, you keep asking. But whatever you are asking will automatically come. If you have something important to ask, you can ask. Keep asking.
No, 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 only these doubts only, sir. Like, why system
Okay.
asking?
Okay. So now find the center of mass of this system. Position of center of mass.
Yes, sir, I'm doing, sir.
Okay. Getting answer, not getting. Any confusion you have, you can ask. You can ask if you are not getting. If you have any confusion, you can ask.
M1 R1 bar plus M2 R2 bar by R1 bar plus R2 bar. That's how you can say.
You are saying M2 R by M1 plus M2.
So no, sir. M1 R1 bar plus.
Okay. There is no R1 and there is no R2, first of all. There is only R. Two particles separated by R. You have to find
Sir,
center
but
of mass position.
sir, down they mentioned R1 and R2. No, sir.
Yeah, you have to find that. You have to find R1, you have to find R2. Are you getting?
Okay, sir. Understood.
What is given to you is M1, M2, and R. That's it.
Okay, sir. I need to find R1.
You can ask.
Getting, sir. I'm getting this. Sir, we get R1 R into M2 by M1 plus M2, sir.
R into M2.
By M1 plus M2, sir.
And what is that? It is, this is the value of,
R1, sir.
huh. R1, okay, you are saying again formula?
It's a formula, sir. R1 equals to R into M2 by M1 plus
Uh-huh.
M2.
Yes, that is correct. And now you have to find R2 so you can subtract from R, right?
Yes, sir. You get M1 by just F1 plus
Now these
F2.
are some of the important points about the center of mass. Position of center of mass is independent of the coordinate system chosen. Wherever you choose your coordinate system, position of center of mass will not change.
Like only coordinates will change.
Only coordinates will change. Its actual position will not change. Yeah. Now the position of center of mass depends upon the shape of the body and distribution of mass. Okay. That's why you can see that in that formula, m is also coming, mass of each particle. Coordinate of each particle is also coming in the formula. Because it depends on the mass of each particle, means how the mass is, and also the distribution of the mass, means R1, R2, X1, X2, these things. If the body is symmetric, its center of mass is located at its है ना, geometrical center or center of symmetry of the body. Center of mass changes, the center of mass changes its position only under translational motion. So this is what I was talking there, you know. So there is no effect of rotatory motion on the center of mass of the body. So if suppose a body starts rotating about its center of mass, then center of mass is not moving, it is at rest, right? So center of mass will move. The motion of center of mass only depends on the translational motion of the body. You can say that motion of center of mass describes the translational motion of a body. If a body is going from one place to another place, its center of mass is also going from one place to another place. Now see this, if origin is the center of mass, then the sum of moment of mass of the system about the center of mass is zero.
Sir, how
Okay.
can we see in rotational motion the center of mass is constant or not affected? So means by equations can we prove, sir?
No, so I am not saying that the center of mass is constant or not affected. What I said, you have to listen very carefully. What I said is that if a body is rotating about its center of mass, then its center of mass will be at rest. And why this is said that it is not affected? Because naturally any body rotate always about its center of mass only. Naturally, I am saying. If you force a body to rotate about an axis, then definitely it will rotate about the axis. For example, door of a room is fixed to rotate about the axis. So door of a room does not rotate about its center of mass. Are you getting? But naturally, if you rotate a pen and keep it on a smooth surface, the pen will not start rotating about axis passing through edge of the pen. It will only rotate about an axis passing through center of mass. So naturally, every body naturally can only rotate about an axis passing through its center of mass. When I'm saying naturally, the meaning is that there is no any other force, no force acting on a body. If you just rotate it and left it, and after that no force is acting,
Sir,
then the
if
body will only rotate about its center of mass. Means if a body is free to rotate without any external force is there, then it will always rotate only about its center of mass.
sir, even weight also should not be there, sir.
Even
Weight mg also should not be acting.
mg you cannot remove first of all, and
Yes, sir.
second is that mg will not affect because it is a central force. So it acts on the center of mass. That's why. So the actual thing is that there should be no any external torque about the center of mass. So then it can rotate freely about the center of mass. Rotation has to do with torque. So mg is acting, but it is not producing any torque about the axis passing through center of mass. That's why mg has no effect in rotation about the center of mass. So if you just rotate and leave it, it will rotate only about an axis passing through center of mass. You can ask your doubts. Keep asking. Now the next is
Every force is a central force, please. I mean, every force act on center of motion in different sets. Only weight is a central force.
uh, speak louder. You are not audible.
Sir, only weight is a central force, or every force is a central force, sir?
No. So gravitational force is central force. Electrostatic force is also a central force, not other forces. Other forces that you can apply anywhere. You can apply force anywhere, but gravitational force, electrostatic force, these forces are central forces. They always act along the line joining their center. Other forces, friction force, it can act anywhere. Normal reaction anywhere. These are not central forces. Okay, now you have to find the center of mass of a thin rod. So here in this case, you can see that rod is now not a single particle, but it is made up of large number of particles. One way to do it by integration is that imagine a very small portion of the rod of length dx at some distance, let's say x from the origin. Okay, and this is called as element. So this is a very small element of the rod. Now the element is very small, so you can treat that element as a particle, single particle, because the element size is very, very, very small. And now if that is the particle, then you can use the formula of center of mass for particles. So xcm, what we do, you know, and like that we can break the entire rod into lot of particles, small elements, but all the element will be at some different distances. Okay, so for bodies the same formula, m1 x1 m2 x2, like that will become x dm. Integration xdm, in place of summation integration will come. This will come in continuous distribution of mass. Here mass is not distributed at x1 and then at x2 and then at x3, different x coordinates. It is present everywhere between x equal to 0 and x equal to l.
Uniformly distributed, we can say.
Uniform distribution is there, or you will say continuous distribution. Continuous because it is present everywhere between x equal to 0 and x equal to l. Between x equal to 0 and x equal to l, there is not a single point. There is not any coordinate where the mass is not there. So it is continuous everywhere. So for continuous distribution of mass, we use this formula. Okay, so after that you will just substitute here dm. Dm is mass of the element, and you will get the center of mass. Okay, so if you understand this, we'll go to the next. If you have doubt, you can ask here.
No
So
doubts.
we have not done anything different. Whatever we defined, exactly same thing. Only in place of summation, we are using integration.
Summation only we call integration of both are
Yeah, summation is integration for continuous distribution. Summation is for discrete. When the things are not continuous, for example, you have to add natural number 1, 2, 3, 4. You will do summation, because between 1 and 2 there is no natural number, but there are infinite numbers between 1 and 2. Are you getting real numbers?
yes.
So discrete addition we use summation. Continuous we use integration. Between any two rational number, you know how many rational numbers are there? Between any two rational number. Between any two rational number, there are infinite number of numbers.
Yes, sir. There are infinitely small limited.
And non-terminating recurring numbers are rational or irrational.
They are rational, sir, non-terminating.
So if it is 2.9 bar, it is rational, and 3, it is also rational. Between these two number, two rational, there should be how many rational numbers? There should, between any two rational number, there is.
Infinite rational number.
So between this 2.9 bar and 3, there should be how many rational numbers?
Oh, there exists no rational number within them.
So then
So
how can you say that between any two rational number there is infinite?
depending upon cases, we need to
So
consider.
2.9 bar is equal to 3 or not?
So if you want to
Or
take, we can cancel, but it's 2.9999.
is it equal to 3 or not equal to 3?
The exact amount it's not equals to 3,
Is it less than 3 or greater than 3?
but it's less than 3 only. No,
If it is less than 3, there will be different, definitely something between it. Find that number. What is difference between 3 and 2.9 bar? Why we never see this type of mathematics? 3 minus this. Okay.
because
Okay.
it's
Think about
difference
all
between
this.
this.
Okay. So understood this? In this, you have any doubt?
No doubt, sir.
No doubt.
Sir, sir, I will
Okay.
read today and I will ask tomorrow, sir.
Okay. Okay, then we'll continue tomorrow. Come up, है ना?
Yes, sir.
Read till now solved questions based on center of mass. Do some derivations, and tomorrow we'll discuss again. You have any doubt? You can ask now.
Sir, no doubt, sir. Tomorrow I will ask
Okay
for
then.
some.
Okay, we'll discuss tomorrow. Okay, bye.